and once again, welcome to Pankaj Echelon Tutorials. In this session, this should be part 2 of my video on arithmetic progression. So this is my part 2, and this is for IGCSE students, and it's from a topic called AP, that is arithmetic progression. In the part 1, I have already discuss the concept of this AP, and in this part 2 I am going to start solving the numericals of this AP. Okay, so right now this is the first one that we are going to solve, and then the second one as well. Okay, so let us get started and uh, see what the numerical says. So numerical number 1 says that the seventh term of one sequence is 7. So I can write this as A7 is equal to 7. And the 17th term is 37. So A17, A17, that is the 17th term is 37, right? And this is an AP, right? The ninth term of another sequence. So there's one more sequence which is a different sequence, and in that sequence, the ninth term, that is A9, is minus 8, and the 29th term, that is A29, is minus 88. Now this is the piece of information we have with us, and they have asked us to find out what the two sequences have an equal term. Find this term. So these two sequences have a term which is equal, okay, which is same, and which is that term that we are supposed to find out. Okay, so going by this question, okay, let us start answering this. So A7 is equal to 7. So here I can write that 7 term is 7. This will be equal to the first term A1 plus 7 minus 1, because n is 7. So 7 minus 1 is 6, and this will be 60. Okay. So 7 is equal to A1 plus 60. And in the same way, I'll get 17th term, which is 37. This will be equal to A1, that is the first term, which we don't know, plus n minus 1 will be 17 minus 1 is 16. So it will be 16D. So we get these two equations. Okay. It's 7 is equal to A1 plus 60, and 37 equal to A1 plus 16D. These are the two equations that we get, right? Now let us try to solve these two equations by simultaneous equation method. So equation 2 minus 1 will give me 16D minus 60 is 10D. A1 minus A1 will be gone. 37 minus 7 is 30. This will give me D is equal to 30 divided by 10, which is equal to 3. So I got the value of D. Let us try to find out the value of A1 from this. So 7 will be equal to A1 plus 6. Now since we know D is 3, that will be 6 times 3. 7 is equal to A1 plus 18. So 7 minus 18 will be equal to A1. 7 minus 18 is minus 11. So my A1 is minus 11. So I get D is equal to 3. I get A1 is equal to minus 11. So my general term, or the nth term, I can write as An is equal to A1 plus n minus 1 times D. This is equal to A1 is minus 11 plus n minus 1 times D is equal to 3. So this will work out to minus 11 plus 3n minus 3, which works out to 3n minus 14. So this is my general term of this particular sequence, whose two elements I was knowing, two terms I was knowing, A7 equal to 7, A17 is equal to 37. Okay, fine. Now let me do the same thing for this another sequence. A9 is equal to minus 8. So going by the same way, okay, minus 8 will be equal to First term, let it be this a1 plus n minus 1 in this case, because this is 9, n is 9, so it will be n minus 1 will be 8. So 8d. Okay, this is my first equation. Second equation says that the 29th term is minus 88. So minus 88 is equal to a1, that is the first term, plus this is 29th term. Okay, so n is 29, so 29 minus 1 will be 28d. Okay, so this is my second equation, right? Now see, in the first part, I have explained you that any sequence, arithmetic sequence or arithmetic progression can be written as an is equal to first term, that is a1 plus n minus 1 times d. And this particular formula I'm using, okay, in these two uh, uh, sequences, okay, in these two AP. And with that, I'm trying to find out the A and D, the A1 and D for both the sequences. So here, if I try to solve this two equations simultaneously, again 28 minus 8 will be 20D, A1 will be going, and minus 88 minus 8 is minus 88 plus 8, that is equal to minus 80. Now this gives me D is equal to minus 80 over a 20, which is equal to minus 4. So I get D is equal to minus 4. Now I'm going to use this D in any one of this equation. Let me use this equation. So minus 8 is equal to A1 plus 8 times D is minus 4, right? So minus 8 equal to A1 minus 8 fours are 32. So minus 8 plus 32 will be equal to A1, and minus 8 plus 32 happens to be 24. So this will be my A1. So I get my first term as 24 and my common difference as minus 4. So my general term will be an is equal to first term, that is 24, plus n minus 1 times d, which is minus 4. This will give me an is equal to 24 minus 4n plus 4. This will give me an is equal to 24 plus 4 is 28 minus 4n. Okay. So these are the two general terms of both these sequences that he has given us. Okay. Now the thing is, he is telling us that the two sequences have an equal term, and you have to find which is that term. Okay, now manually let us do, or let us understand this way. Suppose the two terms are same, this an and this an of the two sequences are same. So you can equate the right hand side, that is 3n minus 14 equals 28 minus 4n. Now when you solve this equation for n, you will get 3n plus a 4n equals 28 plus 14. That is 7n equals 28 plus 14 is 8 plus 4 is 12. 2 plus 3 plus 1 is 4. So n is equal to 42 divided by 7, which works out to 6. So I'm getting n is equal to 6. That is, this particular sequence, both this sequence, okay, this one and this one, okay, they will have the term number 6 as equal. Okay, so which is the equal term? So the answer is the term number 6 is the equal term. But he has asked you to find out this term as well. That means he is asking you to find out the A6 term also, because n is 6, so A6 will be what? Now A6 will be equal to, I can put in any of these formulas, okay, because both the formulas will have the A6 as same. So let me take 3n minus 14. So 3 times 6 minus 14. This is 18 minus 14, which is equal to 6. So I am getting that A6 as 6. Okay. So my answer to this question is the equal term is nothing but 4. Okay. 18 minus 4 is 4. I'm sorry. This has to be 4. Okay. So the equal term is 4. And which is that equal term? It is the sixth term. So the answer is the sixth term of both the sequence is the same and it is 4. Okay, that term is 4. Okay, so this is the answer for this question number 1. Let us quickly do this question number 2. Question number 2 says that the decimal expansion of pi has been memorized to 67,000 digits. We know that pi value is 3.142 dot 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 dot, and is saying that this after the decimal point there are some 67,000 digits, okay, which has been memorized, right? Now one day Casper decided to do a same memory challenge. So he memorizes 10 digits in the first day, on the first day, and the further 10 digits on every day after that. So on the first day, that is A1, he memorizes 10 digits. Okay, so from 1, 4, 2, that way up to 10 digits, he is memorizing on the first day. Then on the second day, okay, he is memorizing 10 more. Okay, that way every day he is memorizing 10 digits more. Okay, so you can say that the D is equal to 10. So for this sequence, AN will be equal to A1 plus N minus 1 times D. So this will be A1. Now A1 is 10, that we know. So I can put in the value of A1 as 10 plus N minus 1, and D also, yeah, I know it is 10. Okay, D is also 10. So let me put that also 10. Now this, if I simplify, I get 10 plus 10n minus 10, wherein this 10n minus 10 gets cut, and I get an is equal to 10n. Fine. Okay. So this is the general term formula for this particular AP. Okay, this was an AP. Right? Now let us see what the question says. The question says, how long will it take him, okay, to memorize the entire digits? Okay, so how many digits are there? 67,000. So when an is equal to 67,000, what should be n equal to? Okay, so if you plug in this value, 67,000 is equal to 10 times n. So n will be equal to 67,000 divided by 10, which will give you 6,700, and this is nothing but days. So the answer to this question is, how long it will take? So it will take 6,700 days, okay, for Casper to memorize the entire pi value. So these were two questions based on arithmetic progression, and in the next video I will come with more and more numericals on AP. And for today, that's all. So see you in the next video. Till then, bye. Take care, all of you.